and one particular station starts transmission, there is a possibility that two other stations may also start transmitting at the same time, right, and may result in collision, right? But if the medium is idle, no other station is transmitting, the one particular station will transmit and wait for the acknowledgement. That acknowledgement, it will wait for the positive acknowledgement, that will be equal to 2 into TP, right? Round trip propagation time. And in during that period, if the station doesn't receive the acknowledgement, it retransmits the frame, right? And if a collision occurs and once again the station transmit, अच्छा आप बता सकते हो कि सबसे डेडलीस्ट पॉसिबिलिटी क्या हो सकती है? अगर आप सोचो that suppose one station at the same time, suppose we will study this part also, that one station transmits, let us say station A transmits first, and at the same time station C, D, Y also started transmission, right? So three other stations also started transmission, and what happens after some time? A collision occurs, right? So once then they will wait for some time because the collision has occurred. Then there is a possibility that all the stations may again start at the same time and may result in collision, right? Because what is happening, that this station is transmitting, okay? So if this station doesn't receive the acknowledgement by, suppose at the same, by 2 into TP time, okay, it will assume that some collision has taken place and it will retransmit the frame, right? ऐसा नहीं है कि only transmission के time में ही ऐसा हो सकता है. There is a possibility when a station is retransmitting a frame, there is a possibility of collision again, right? So if there is no acknowledgement received, the station assumes that the collision has taken place, okay? So collision can occur only when that more than one user transmit at the same time, okay, and that cannot be avoided, but we can reduce it by keeping this frame transmission time higher than the TP. As I said, in CSMA, the station has to, if the medium is idle, it will transmit. Otherwise, the station has to wait. So now the question arises, how long a station will wait, okay? So it will depend on, so this is also defined using 3 persistent strategies in CSMA, okay? So what is that persistent strategies? Persistent strategy, there are 3 types of persistent strategies. One is called as a one persistent strategy. This type of scheme is also called as a selfish approach. What happens? The station starts, it sends the medium, okay? It finds that the medium is free, it transmits immediately without thinking anything, okay? Whether the other station may transmit or without thinking, immediately the medium is found idle, it will transmit immediately. But if the medium is busy, okay, it senses the medium. If the medium is busy, it will keep sensing the medium until the medium becomes free. And once it finds the medium is idle, it will transmit immediately, okay, without thinking कि वहां से कोई और स्टेशन ट्रांसमिट कर चुका होगा, I should wait for some time. ऐसा तो नहीं है कोई farthest end से some other station has started transmission which has not yet reached to me to this particular station. Without thinking that, it immediately transmits, okay? So this type of strategy, okay, may result in more number of collisions because they don't think anything about, they think about themselves. The station think about themselves. They have to transmit immediately whenever they are finding the medium as idle, right? This type of scheme is called as a one persistent strategy. that they will keep sensing the medium when the medium is busy, and once the medium becomes free, they immediately transmits without thinking anything. That may lead to more number of collisions, right? And this scheme is called as a selfish approach. There is another scheme, another persistent strategy, that is called as a non-persistent. Non-persistent, this type of persistent strategy is also called as a differential scheme. What is there in this? Basically, the station first sends the medium, okay, and finds that the medium is free. It's fine. It immediately transmits the frame. But no, it immediately doesn't transmit the frame. Sorry, it sends the medium. Okay, even the medium is free. In this scheme, it doesn't transmit. Why? Because it assumes. It transmits immediately. Okay, if senses the medium, it founds free, it transmits. But if the medium is busy, okay, if the medium is busy, it founds that the medium is busy, it waits for a random amount of time. And this random amount of time is calculated based on some probability distribution. Okay, so this type of time is called as a back-off time. Okay, we will discuss about the exponential back-off time. Okay, back-off time is nothing but it chooses some value r. Okay, it chooses some random value r. Okay, and it waits for that much time. Initially, it waits for 2 to the power 0, then 1, 2, 3. I'm coming to that. So non-persistent में क्या है? The station first senses the medium. The medium is free, it transmits. It's fine, right? But if the medium is busy, it waits for a random amount of time. Random amount of time means it will wait for a 1 round trip time, then 2 round trip time. So every time the station finds the medium is busy, the waiting time increases in an exponential manner. So that is called as an exponential backoff. Assuming that, because initially it finds the medium is busy, then it waited for some random amount of time, it waited for 1 round trip time, and once again checked the medium and found that the medium is free, right? Then it will transmit. But again, if the medium is busy, like it waited for random amount of time, it senses the medium, and once again it is busy. So next time it will wait for 2 to the power 1, right? 2 round trip times. And once again, after waiting, it will again sense the medium, and again if the medium is busy, it will wait for 4 round trip times, right? So the wait for the station will increase exponentially. But in between, if the medium is free, when the station is waiting, in between the medium is free, then the station is unable to utilize that, right? So this results in a wastage of capacity, because when the medium was free, there was no taker, right? This station is contending for access, but when the medium becomes free, this station is unable to use it because it is waiting for a random amount of time, assuming that some other station is using it, right? So this creates a differential approach, right? The stations contained for a differential time period, because the station which is coming, suppose one station is waiting for 1 round trip time. By the time during the time this particular station is waiting, the other station comes and finds the medium is idle, it will transmit, right? So there is no kind of priority here that this station came first, so it should be given first priority. Generally hota hai na, first come first serve, like that. But that is not followed here, because the station which is waiting will wait for a longer period of time. The station which is coming will get like a LIFO, right? LIFO जो होता है, जो आप stack implement करते हो, stack implementation is done in two ways, first in first out, right? The other one is last in first out. इस स्कीम में क्या होगा, if the first station is coming and it is not it finds the medium is busy, it is waiting for a longer period of time, okay, then the in between another station comes and it finds the medium is free, it utilizes it. So last in gets first out, right? So it's create a kind of a LIFO, right? This exponential backoff creates a kind of a LIFO, last in first out effect. Okay. So is there any doubt in this?
No, sir.
Why we are studying these persistent strategies? Because in CSMA, that is carrier sense multiple access, if the station senses the medium, if the medium is free, it transmits. But if the medium is not free, what the station will do? So that is being dictated by these three. There are three persistent strategies, right? One is called as a one persistent, that is called as a selfish approach, because the station doesn't think about the others and transmit immediately once it finds the medium is idle. On the other end, there is a non-persistent scheme where the station once finds that the medium is busy, it waits for a random amount of time, right? And then once again senses the medium, and if it is again busy, it increases this back of time is increases exponentially, right? And that results in a wastage of capacity. So the first scheme has a disadvantage of more number of collisions, while the second scheme has a lot of wastage, right? There is a third strategy which is just a combination of these two, that is called as a P persistent. So it basically it combines the advantages of both the schemes, right? Because non-persistent is having an advantage that it reduces the possibility of collision, though the stations has to wait for a longer period of time and capacity is wasted, but still it is able to manage the number of collisions. On the other hand, the one persistent scheme, it reduces the idle time. Okay, in case of a one persistent or the selfish approach, the stations, though there is a possibility of more number of collision as the load will increase, if you go for a higher load conditions, it will result in a large number of collisions, but it saves the idle time. It reduces the idle time, though saves the capacity. It means the throughput is higher, right? So what is the combination that is called as a P persistent, right? So here, what is there in this scheme, that if the medium is idle, right? If the medium is idle, transmit with probability P. Okay. So medium is divided into time slots. So time slots is equal to the maximum propagation delay. The time unit is equal to the maximum of the propagation delay, right? Each time slot is divided with the maximum of propagation delay. And you know that in probability we have the combination of success is P, and if it is a failure, it will be 1 minus P. Q will be equal to 1 minus P. So what is that? If the medium is idle, it transmits with probability P and delay 1 unit time with probability 1 minus P. So nothing but Q. 1 minus P is what? The Q. So if the medium is busy, it continue to listen until the channel is idle and repeat step 1. So in case if the medium is free, transmits the frame with probability P and wait for the acknowledgement, that is nothing but how long it should take for the acknowledgement to come back, the maximum possible round trip time. So that is the maximum propagation time, that in that period the station expects a positive acknowledgement. So if the acknowledgement doesn't reach, okay, so if the acknowledgement doesn't reach to the station, positive acknowledgement, it has to retransmit. So if the in that case, it has to delay its transmission by 1 unit delay and then retransmit again. Again it has to go back to step 1. Okay, so if the medium is idle, it will transmit with probability p and it will wait for with 1 unit probability 1 minus p. Right, if the medium is busy, it will continue to listen until the channel is idle and repeat step 1. So once the channel becomes free, it transmit with probability p and wait for the acknowledgement with probability 1 minus p. Right, so if the transmission is delayed by 1 unit time, because if it is not finding the channel is free, or if the acknowledgement is not coming in this period of time, it repeat step 1 again. Right, but this scheme has a disadvantage. Can you say what could be the effective value of P? Anyone? This is very interesting. Can you say what could be the effective value of P? Anyone? What could be, what value of P you should choose? See, if you choose a value of P, suppose there is a case when you have n number of stations, they are having a frame, they are having some data to send. Okay, when some already a transmission is taking place, so that means n number of stations are contending for access, because they all are having a frame for transmission, so they all are contending for access while a transmission is taking place. So once this transmission is over, all the n number of stations will sense the channel, right? So at the end of the transmission, the expected number of stations will be NP is much greater than 1, because n number of stations with probability P will try. So what will happen? Are you following the case? That if you choose the value of NP much greater than 1, what will happen? Because suppose some transmission is already going on and n number of stations are contending for access, and once the transmission over, all the n number of stations dump their data onto the onto the channel, and what will happen? There will be continuous collisions will happen, right? So to avoid this situation, what could be the value of P? So P should be made small and P should be made much smaller than 1. So what will happen? What will happen if you take a value of P as 0.1, you have taken value of 0.1. So you will be transmitting with a probability of 0.1. Then you will be waiting for an acknowledgement with a probability of 0.9. So that means you have to wait for 9 unit times before transmission on an ideal line, right? So if you choose a higher value of P, right, that will result in large number of collisions. And if you choose a very small value of P, it will result in a longer delay. The capacity will be wasted, right? So one has to choose this value very wisely, right? Because a higher side, considering the load conditions, whether you are working in a high load conditions or you are working on a light load conditions, this P value is chosen, right? Now is it clear or any doubt is there? Any doubt?
No, sir.
Okay, so I'm moving ahead with CSMA CD. Okay, this is called as carrier sense multiple access collision detection. I had given you a hint of this scheme. This is a very interesting, and it is used in your what? It is a MAC protocol. It is used in which scheme? मैंने बताया था आपको, बताओ कोई, कहाँ यूज होता है? It is written here, IEEE 802.3 Ethernet LAN. We use this as a MAC protocol. Which LAN you people are using? There, we use this as a MAC protocol. Now I have a first question. Who will answer? That though we had seen that there are three persistent strategies, right? There is a one persistent, there is a non-persistent, there is a p persistent. I just want to tell you that CSMA CD, because you know that the one persistent strategy is also known as a selfish scheme, right? The station keeps sensing the medium and transmit immediately once they find the medium is free without thinking anything, right? And this scheme results in maximum number of collisions. But still, CSMA CD uses this scheme, one persistent strategy. Can you say why? Can you say? We have discussed. Can you say? What could be the reason of using this one persistent scheme by CSMA CD? Huh? You have seen in non-persistent, right? In case of non-persistent, what was the disadvantage? Wastage of capacity, right? In case of a p persistent, there is still a trade-off in choosing the value of p, right? Because if in high load conditions, if you choose the value of p are higher, right, it will result in more number of collisions. And for light load conditions, if you choose a value of p as small, one station has to wait for a longer period of time for transmission, even though the link is free for transmission, right? So keeping in view these two things, right, uh, uh, the CSMA CD uses one persistent strategy, though it results in more number of collisions, right? So how does it work? Because here we have to detect the collision, and it utilizes, because it is based on CSMA. So CSMA uses the feature, CSMA uses that the propagation delay should be smaller than the frame transmission time. What is the advantage of that? If the frame transmission time is higher than the propagation delay, the moment the station launches its frame in the network, right, the first bit of the frame reaches to the farthest end of the network, right, if the propagation delay is smaller as compared to the frame transmission time, so that the other stations which were supposed to start transmission, they will refrain from transmission, right? So how does it work? It works like the station senses the medium, right? If it is busy, because it uses one persistent only, so it keeps sensing the medium. If the medium is busy, it keep on sensing. Once the medium becomes free, it transmits the frame, because that was the property of a one persistent scheme. And then it checks, because it detects the collision, right? It detects. This scheme is detection of collision. And then it detects collision, it tries to detect the collision. If the collision is not detected, your frame is through. But if it is detected, the collision is detected, then a jamming signal is to be sent by the nearby station, so that the other stations can understand that collision has taken place. So they should avoid transmission during that period until the network get clear with the collision, right? I will go to that point later, but first of all, I like to ask you that how the collision will be detected. Can you say, anyone? How the collision will be detected? You can see there is a baseband LAN. Okay, this is a baseband LAN, right? Can you say how the collision will be detected? We discussed it once. Huh? Anyone? Karthik, can you say? Shubham, Sahil, anyone? Can you say how the collision will be detected? How will you detect a collision, right?
Sir, the transmitter will detect the noise which will come after collision.
Right. So not you cannot say noise. Actually, the signal strength will be higher after collision, right? Suppose if you are transmitting a 5-volt signal, because this is a bus lane. So how the signal travels in the lane? The signal travels in the form of voltage pulses. So whatever data this station is transmitting, it is launching on the it is transmitting on the link, right? Whatever the bit pattern, that bit pattern will travel in the form of voltage pulses, right? So once they are traveling in the form of voltage pulses, as you said that the transmitter, suppose if the transmitter is transmitting at a 5-volt signal, right? And if the two 5-volt signal collides, okay, what will happen? The signal energy will exceed 5-volt, right? So this is how the collision is detected, right? Higher energy level will be detected, and the two stations, suppose station A is also transmitting, station D is also transmitting. So at the same time, if the collision occurs at some place, right, at this place, what happens? The nearby station, because the stations are unaware that the other stations have started initiated a transmission. So once the station A is transmitting, at the same time D also feel that the medium is free, it should also initiate transmission. When both the station starts transmission, and simultaneously at some point the frames gets collided over here, right? So the nearby station, okay, the nearby station which senses the collision, right? Suppose the nearby is station C or station B, whoever senses this collision first introduces a jamming signal in the network, so that once the jamming signal is there in the network, no other station will start transmission on the network, they will avoid, okay, so that the further collisions can be avoided. But there is always the possibility of collision, right? So once a collision occurs, it will result in higher energy levels, and the nearby station which detects the collision is responsible for um, sending a jamming signal in the network, so that other stations can avoid transmission during that period of time. Okay, I am stopping it here, we will discuss it, it's quite interesting, and then how do we do that. Okay, so thank you for your active